Hey guys, it's Mr. Paulo, and today we're going to be talking about Newton's second law. This triangle down here represents the relationship between force, mass, and acceleration. Newton's second law deals with this relationship, okay? So if we are looking for force, then we're going to multiply mass times acceleration. If we are looking for mass, we're going to divide force by acceleration. And if we're looking for acceleration, it's going to be force divided by mass. Alright, here's an example. So this guy applies force to an object with mass and it accelerates. Okay, and here's the formula for that. Now, if we take that same guy and we increase the amount of force he has but keeps the mass the same, then your acceleration will increase because force is tied to acceleration. The greater your force, the greater your acceleration. If we keep that guy from the very first time, but we give him we give him more boxes, right, and add more mass, then he's going to lose acceleration, okay, because mass is tied to acceleration. The greater your mass, the smaller your acceleration. So that's how they're all tied together in examples of that. Let's work a problem. With what force will a car hit a tree if the car has a mass of 6,500 kilograms and it is accelerating at a rate of 4 meters per second? First thing I need to do is figure out what I'm solving for. That's going to be force, because it says with what force. So force is at the top, okay? Next thing I'm going to do is I'm going to look for my other unit. So I have 4 meters per second squared. Because meters per second squared is the units for acceleration, I know that this is my variable for acceleration. Over here, 6,500 kilograms. I know that kilograms are mass, so that's my mass. Let's write out the formula for this problem. So it's going to be force equals mass times acceleration. So the first thing I'm going to do is I'm going to plug in the units that I know. So 6,500 kilograms is my mass, and my acceleration was 4 meters per second. When I multiply those together, I get 26,000 newtons. I have a newton because force, remember, is going to be recorded with newtons as their units. Let's do another one. What is the mass of a car if it accelerates at a rate of 3 meters per second and hits a parked car with a force of 18,000 newtons? Okay, let's figure out what we're solving for. That's going to be mass. What is the mass? So we know down here that I'm solving for mass. So whatever I have to do, I have to probably divide force by acceleration. So we're going to put down our formula. Force equals mass times acceleration. I'm going to look at my variables here. My first one, I know it has newtons. So this is going to be my force. Alright. And this other one up here, we'll write that down. 18,000 newtons equals, I have this one up here, 3 meters per second squared. Meters per second squared is, if you're guessing acceleration, you got that right. That's my acceleration, so I'm going to write that down. So I'm going to put m for my placeholder times 3 meters per second squared. Now, I need to get this m by itself on this side, so I'm going to divide by 3 on both sides. So 3 over here divided by 3 over there. That gives me 6,000 kilograms. And since we're solving for mass, our units are going to be in kilograms. Let's do one more. What is the acceleration of a soccer ball if it has a mass of 0.8 kilograms and hits a goalie with a force of 30 newtons? Alright, let's look at this. We're going to write the formula down first. Force equals mass times acceleration. And we're solving for acceleration. Okay? What is the acceleration? It tells us right there at the very beginning of the question. Now I'm going to look at my units. I have 30 newtons. Newtons is a unit that deal with force, so I know I have force here. And 0.8 kilograms. I'm going to write force down first. So 30 newtons equals, now I'm solving for my mass, like I said earlier, I got ahead of myself, 0.8 kilograms. That's going to be, kilograms is mass, so I have my mass there. So now I have all my variables to start plugging in. So it's going to be 0.8 kilograms for my mass here, times A. I'm going to put a placeholder there because I'm solving for A. Now I need to get that A by itself, so I'm going to divide both sides by 0.8. When I do that, I get 37.5 meters per second squared, and that's my acceleration for that problem. That's how Newton's second law works. That's how Newton's second law is tied to force, mass, and acceleration. And that's how you solve problems with force, mass, and acceleration. You need to memorize this little triangle down here, and once you have that down, these problems shouldn't be a problem for you. Pretty simple. Hope that was easy for you to understand. If you didn't get it, go back and rewatch it. Have a great one, guys.